really excited to see everyone today. I'm Alex Rice here with Yogurt. We're the co-founders of HackerOne. Do a personal intro in a second. Both really passionate about building a safer internet because internet's not so great today. We got some work to do, and we're going to dive into a topic we're both pretty excited about. But let's introduce you to ourselves first to start. Yogurt, you want to go first and kick things off?
Yeah, hey everyone. Very excited to be here today. Like Alex said, I'm Yogurt. I'm one of the co-founders of HackerOne, and I'm a software engineer here at HackerOne. I spend most of my time on AI these days and figuring out how AI and humans can work together to empower the world to build a safer internet, even more so than we did in the past.
Well, and I'm Alex, another co-founder of HackerOne. I used to be an engineer. I don't think I can claim that anymore. Yogurt was just roasting me the other day. I have written code in almost 2 years now, which is it's not great, but I used to be an engineer, and I wrote a number of applications that did not survive on the internet. That set me off a new career arc into product security, is where I spent most of my career. Still really passionate about this stuff. But we're going to dive into a topic we're pretty excited about today around how the promises between security and development teams haven't been the smoothest relationship, and what new opportunities we're seeing on the horizon to rethink that. I know we'll probably get into a few different areas throughout this talk, but really the premise of it is there's one topic we think is worth some consideration, some real thought leadership here. We think it might be better if we could put security early in the development process and find stuff before it goes out into production. We're calling it shift left. It's some real original thought leadership for everybody today. Gilbert, what do you think? Is this a good idea? Should we on principle?
Yeah, I mean, bug bounties are considered a last line of defense, right? And so obviously we think that that is definitely a good thing to have, but it's almost in a way too late. Like it means that all of the processes that you have in place miss the security vulnerabilities that pop up during in your bug bounty program. And so building out feedback loops for ourselves and for our customers to ask ourselves the question like, well, why didn't we find it earlier? I think is a fascinating question to dive into. And now we're here with AI and humans, and maybe we have kind of another shot at properly shifting left.
That's really the crux of what we're going to get in today. Like, this is a good idea in principle. We'll talk a little bit about how it's going and dive into what we're excited about going forward. But also just want to say, I hope to make this pretty conversational. We've got chat open for everybody, trolls and well-intended folks alike. And there's a structured Q&A function that'll pop up if there's something you'd really like us to answer live. So please feel free to use that as we dive out through the day. Being a little bit cheeky here at the beginning, we do really think shift left is a good idea in principle, but like most things in security, the implementation hasn't lived up to expectations. Could have gone a little bit better. So I just wanted to spend a second here at the beginning talking about our observations of where we got this the most wrong, despite best intentions. Shift left just is not working across most engineering teams that you talk to, and increasingly most security teams that you talk to. Hopefully, this isn't too controversial of a statement now. It takes a little bit of introspection for security teams. It would, despite our best intentions, it just the sentiment is not there and the results are not there. And there's three things in particular that we spend the most amount of time examining, and like, why not? Why are so many bugs still making it up to production? Whether that's in a breach or a bug bounty program or a pen test, all areas where we would much rather catch things sooner. The first reason is we just drowned developers in noise. We took traditional SaaS tools, security tools, inserted them into a pipeline, and traditional SaaS, DAS, SCA just wasn't designed for developer productivity. There's just too many false positives, and we've ended up with just a backlog of work that is not relevant for those teams. The second thing you just hear from every development team is sometimes there's just unrealistic expectations around fixing things. It is trivial for a security tool in 5 minutes to generate 5 months of work for a development team. And that asymmetry there of just finding issues isn't enough. We have to be realistic about what goes into fixing some of these issues. Again, hopefully not too controversial, but it's helpful for us to spend just a second here level setting on those pieces. The final one is security teams are under pressure, sure. Development teams more so. Like the pressure to stay competitive, to ship, to meet launch deadlines is ever increasing, especially as so much of this ramps up. And tools that prioritize security over productivity are inevitably just going to continue to be a source of friction. Some friction's okay, but we can't act like friction is just an okay part of this process, not explicitly designed for how to make sure builds keep working, that workflows are designed for developers, and that productivity is a priority in these systems. I'm actually kind of curious everyone's sentiment on this because everyone's got kind of different takes on it. So I asked the member team if they could put a poll here. I'll be impressed if this works. Zoom, I see it. Hopefully everybody else sees that now. I never know how these goes. Just curious everyone's sentiment on whether you're on the receiving end of some security in development or on one of those teams. Curious everyone's perspective on how that's going at the organization, all the way from it's not great to we're crushing it. Let me just get a little bit of color from folks on how's it going. Ever anything to add on your shift left experiences while we wait for a poll?
I've been on both ends, and it's hard. Like I think the tools, like to your point, I think there's a lot of noise. I think there's alert fatigue that kicks in. I think people stop paying attention, even though there's actually good value out of those tools. And like you said, I think the intentions are right. I think we just haven't figured out exactly how to do it better yet. So.
Well, I appreciate everyone's honesty in the polls. No one is crushing it. No one scored themselves 5. Sometimes a little introspection is good here. But there's 30% of them said it was good. They're doing pretty good at finding and fixing issues. I'm encouraged to hear that. So as folks have any observations to share on that topic, would love to hear what's working and what's not. But then there's a bigger percent. So 45% of folks say it's either terrible or needs improvement, which is what we hope to talk about today. So let's get into it. We think it's worth revisiting this shift left concept because there's this new thing coming. Like, if you haven't heard of shift left, I hope you've heard of AI. It's kind of the thing right now. There's an incredible amount of hype around it, but there's also some really interesting potential that comes here. So we think it's worth revisiting some of the core tasks of finding and fixing bugs early in development. Where can AI help? And are there things that it can solve here? And some of those key things, like, can it gain context and provide feedback? Can it prioritize risk? Can it filter noise from some of the legacy shift left tools? Can it find and fix vulnerabilities given some code? And the current best estimation of this is maybe eventually, but definitely not yet. The state of the art out there is pretty unencouraging about what it does. This is an example that we found of one of the AI security bot that is posting a really well thought out comment here around here's what you should consider, and then the code author responding back with it. I'm doing exactly what you just suggested in that comment. That's literally what the code does already. All of these systems hallucinate and cause problem. And anyone who's interacted with AI in any context probably shouldn't be surprised by this. And so we need to think about how we apply this more appropriately. And we evaluated this. One of the things we're most encouraged by is there are some rays of value in here. And so what we'd like to ask is, can AI as a tool for humans in a process start solving some of these problems? And this is the area we've specifically been iterating on over the past year, is where does a more human in the loop approach to AI, applying AI to very specific tasks, not asking broad questions of like, is this code secure? We're going to get tons of hallucinations, but where can we tightly couple AI with humans, give it specific work, and get some value? And there's a few things we wanted to run through with y'all today that we think are really promising for the future. Robert, I think you're going to dive into the first one here.
Yeah, let's do it. Yeah, we got a bunch of stuff to cover today, but I'm very excited about this. Some of the examples today will be a bit more technical, including this first one. So bear with me. So to set the stage here, let's consider an application where a user can track invoices. The code that you're seeing on the screen is what would be executed when a user wants to see an invoice in the application. And we'll use this kind of example application throughout our slides today. Uh, for a human that is familiar with the code base, answering the question whether this code is secure is perfectly doable. Based on the knowledge that they have about the code bases, they know the implementation of the invoice service, the application controller, the return value of current user, and the implementation of the find invoice or raise method. And so all that context enables them to answer the question whether this is secure. On top of that, they may have a local developer environment that allows them to step through the code and really test it. But an AI doesn't have any of this context. So in order to have an AI give feedback on code, we need to extract context from the code and its version control. So the first thing is extracting relevant context from the commit history. And by stepping through each change in a repository, we can extract information about prior security vulnerabilities that have been remediated and how they were remediated. It could also pick up on unique coding patterns that the engineers have and how key security mechanisms are implemented, like authentication and authorization. So this context that we would extract gets stored in very small snippets that the AI can query at a later point. This is very similar to how a human becomes more and more familiar with the code base over time. So the next piece here is to extract information from the code base to give an AI code navigation capabilities. And this is largely a solved problem that most code editors implement too. There are very rudimentary implementations like C tags or more advanced implementations that leverage language servers, for example. So at scale, we don't have the ability yet to run the code due to the complexity of different application stacks. So we opted for a solution where we use tools like Tree Sitter to create syntax trees of the code that we're analyzing. And then these syntax trees are queried for two things. One, the definition of symbols, and two, the reference to a symbol. And so the code on the screen highlights the definition of a class, a method, and a variable. So that's kind of the first layer that we would extract from those syntax trees that we get. Then on the flip side, here are some of the symbol references in the same code. So by extracting both for the entire code base, we can construct a call graph to understand the flow through code. So when AI lacks context of a particular symbol, it can now look up the location and the definition of it through this graph. This concept can be proven pretty easily because more complicated at scale due to the isolation of applications in the same code base, like monorepos, third-party dependencies that we may not install, and mixing languages all together. So let's go back to the question that we asked earlier. Will this update create a vulnerability? So now that we've analyzed the repository, we can kind of come back to this question. And so let's look at how an AI agent can answer this using the context that we've extracted. So most people know that language models return text when asked a question. But most modern language models also have the ability to respond using a structured format like JSON. OpenAI calls this function calling, and Anthropic calls it tool use. So this can be used to give an AI functions to query for relevant context and navigate a code base to load the relevant code to understand code flow. So this is important for two reasons. One, it keeps the context loaded into the model relevant. And two, it avoids exceeding the token window that models have. As most of you probably know, almost all code bases are far too large to load into a model entirely. So we have to be selective here about what we give to the model. So here's a flow chart of what that looks like on a conceptual level. The first call to the AI consists of three components: the code change or the diff that you have a question about, in this case, that would be the diff from the previous slide, some basic relevant context about the repository, and then our question whether this change introduces a security vulnerability. So if we wouldn't have given the AI the capability to navigate the code base, it would have hallucinated an answer where it assumed the implementation of any of the referenced components or classes. So and that would actually result in more work for a human.
Yeah.
However, because we've told the AI that it can look up symbols, it first responds with a query to look up the implementation of the invoice service. And if you go to the next slide, Alex, you can look at what that would look like. So this gets sent back to our agent, which then responds with the contents of that class. However, when the AI looks at the implementation of that file, it realizes that it doesn't have context of the referenced invoice model. So because it still doesn't have enough context to answer the initial question, it sends back a reply that requires the definition of the invoice model. So only when we then send the implementation of the invoice class can the AI answer our initial question. So this is an oversimplified flow chart of this process. In large systems, it is not uncommon for dozens of files to be loaded into the model before it answers the question. And but because it has the capability to kind of navigate the code base, it traverses that code graph or call graph that we talked about earlier in order to load all the relevant information prior to answering the question that we have here. And then on top of that, there are other functions like looking up similar files or querying a threat model or querying for how authentication is implemented. And those all refine the accuracy of the model to answer the question that we have about the code. So, Alex, that's kind of the foundation that we require in order to answer any question. And maybe you can dive a little bit into one of the use cases that we use that for to assess risk and help prioritize.
Yeah, that's exactly right. And it's really interesting to see what needs to happen for an AI to start behaving like a human in a code base. But we quickly realized one of the other things that a application security engineer or a more competent software engineer does when providing context and assessing feedback is they need to prioritize code changes and assess risk across a huge number of changes here. So the next question we spent some time on was, can AI effectively prioritize risk across a massive code base? And you realize pretty quickly that the foundational language models can't do this. If it will hallucinate for anything. You give it a function and you ask, does this code look risky to you, or any of the risk associated with this code, or given these 50 files, how would you rank the risk of this? It's just not something that language models can do out the gate. So we tried to train a slightly different flavor of this model with a big training set data of actual real world vulnerabilities, fine-tuned for that specific task of, can you kind of assess risk in this? Like, is there risk if I am doing something relatively benign in a unit test versus the risk of changing something in an authentication flow or handling PII? These are things that intuitively security engineers build up over time, but language models lack kind of in their native capability. And so when we give them this task of assessing changes across a broader code base, we really need to first train a fine-tuned model on what does risk look like in a code base. And that starts from a ground truth. We started from a big corpus of open source findings, a bunch of findings from our bug bounty program, to really try to task a model to identify these hotspots and fine tune for that specific use case. We're finding that it's actually pretty capable at, given large code bases or big code changes, or whether it's just the velocity of it, if there were 100 different PRs created today, it starts getting pretty effective at pointing out the areas where you would want to go deeper. And it turns out this is pretty essential for even an AI to do secure code review at scale, or to ask questions about code bases at scale, because not all of these things are created equal. And if you ask AI to just apply a similar level of analysis across all files, the hallucinations that you see and the useless information you get back just goes through the roof. So once we've segregated all of those, you can start to produce a work queue for your AI in a hotspots feature and the human analysts that are supporting it. So now we've got a prioritized set of focus areas of a given code base during a period of time. And from that, lets you get really specific into individual changes across a large data set and start to go back to some of the context and prompts that Yobert was just demonstrating for us a second ago. So if you take that approach that Yobert just had and you apply it to every line of the code base, not productive. You don't get great results. You first take a separate model that's prioritizing hotspots and high risk areas within the code base, and then you do the exact same approach in this sequenced order. You start to get really interesting findings where AI can start asking important questions for follow-up. It can call out individual risks. It can flag and fix issues a little bit more autonomously. But what's key to getting there is first this risk assessment, not of code. And this was a pretty important breakthrough in our approach to getting some value out of AI in our implementation. So wanted to just give you a little bit of color into this piece of like coupling AI with humans in a structured context. We think there's opportunity for AI to start doing a pretty impressive job of ranking the relative riskiness of functions and code changes at pretty impressive scale. But we can't stop there. We got other questions we want to ask our AI, particularly in the context of what current shift left looks like. So I was going to turn it back to you, Albert, to tackle one of our next questions for AI here.
Yeah, let's see if we can also filter SAS findings. Like I said earlier, every engineer agrees that static code analysis tools produce too much noise. They often take it for granted because there's also clear value in using them. But the noise often leads to alert fatigue and people paying less attention to the results. So let's consider this code change where environment variables are serialized into an exception. That a static code analysis finding was surfaced to the code author here, but not only is it a false positive, it also lacks any form of contextual information about why exposing environment variables is problematic in this context. So similar to the agent loop that I showed earlier, we can task an AI to navigate the code base and determine the applicability of this finding. In this example, it would pick up on the fact that this code is only executed in a local developer environment, and it's therefore okay. On the flip side, if this would be a legitimate finding, the AI could provide additional context back to the code author to understand the security implications of this change. For example, that API tokens are leaked to the end user, or an error logging tool like Sentry, if the exception would be raised. So let's shift gears a little bit. Let's talk about something that I'm very excited about, which is identify.
Go
ahead. Yeah, go ahead.
I just wanted to hype this one up a little bit more because this was the first really concrete use case that we got production value out of applying humans plus to it. It didn't start from asking AI to do things. Everyone is running some type of security tooling today, or most organizations have run or are running something in the past that produces a set of potential security alerts or potential security findings that need to be investigated. And the norm at too many organizations is either just ignored or they're not analyzed. And we think this is one of the lowest hanging fruits in applying AI to a shift left program, is helping get more value out of the existing noise that's coming, because there's some gems in there. There is some value out of the SaaS tools. They're pointing out things that warrant investigation. And in a perfect world, you could give this SaaS finding to a developer and they'd be like, okay, cool. I investigated, I understood, it's actually safe because in the development environment, everything's good. In reality, developers just aren't interested in doing that relative to the amount of volume that they have. And this was one of the first encouraging use case we landed on. And so I wanted to really make sure everyone, if you take nothing else away from this one of a traditional feeding raw SaaS findings to developers is not something we should be doing a year from now.
Yeah, thanks for that, Alex. That's awesome. Um, yeah, let's see if we can find a vulnerability using AI and humans here. Um, so the benefit of applying AI to identifying security vulnerabilities isn't to replace the static code analysis tools, but instead to complement them with findings that are very hard to find using those tools, like business logic security vulnerabilities. So let's go back to our initial code example. The AI spotted a potential security vulnerability because the code no longer checks that the authenticated user is the owner of the invoice. So similar to the output of a static code analysis result, it can output this as a scanner result for a human to confirm. And the way this works at scale is by first letting an AI build a set of security questions it has based on the code base and the context of the code change. Very similar to how the hotspots model kind of steps through a very large change and then asks itself a bunch of questions to answer. The way the way the reason why we're going down this road is because we want to mimic how a security engineer approaches a secure code review. So for each of those questions, it would then try to answer it using the functions that it has available. Again, very similar to how a security engineer would approach this. And so for anything where the AI believes there are potential security implications, a comment gets posted back to a human. So this is very exciting, but you can still ask, so what? So let's look into the last use case that really brings all of this together. So when an AI is asked about how to remediate a vulnerability, it often comes up with abstract advice that isn't actionable. Since the AI has the ability to navigate the code base, it can also look for ways to solve the potential security vulnerability and make the comment actionable if it is confirmed. So in this case, the AI does not only highlight the issue here, but it also includes a code example of which function to use instead. So from there, it could even provide a code patch that a reviewer could relay to the code author here. And for anyone that has ever asked an AI without any context on how to remediate a security vulnerability, you will often see that it comes up with very kind of abstract remediation advice that is that you still have to perform a lot of work for, or you have to really know the code base in order to make that actionable. And so we're short-circuiting all of that by really bringing the capabilities that to an AI to navigate a code base and provide it kind of historical context about how the code base got into this state. So because of bringing AI into the mix here, we significantly shorten the time for a human to become familiar with the code base and provide a high signal environment with actionable feedback and advice. All right, that was a lot, but we really wanted to provide some details here of what is possible with AI and humans today. So going back to our original question of whether an AI plus human in the loop approach can solve shift left, we believe it does. And Alex will give a quick overview of how we're bringing everything together right into the developer workflow here.
Thanks, Hubert. Yeah, I hope everyone, this is the core thing we want to get across the presentation today is we think this is an area of rapid innovation. We think shift left is worth revisiting with AI. There's so much cool innovation happening here. And if you're starting to give up on the concept of shift left, we hope everyone walks away from this a little bit re-encouraged of that. So we're going to spend the next part of this showing one practical example of how we tied all of this together. But there's one question in the chat I wanted to tackle here around what kind of AI is behind the analysis and fixed remediation, LLM or mix of LLMs. Yeah, you know, want to do a little bit more color into what we've seen the most success with there.
Yeah, combination of two models here. So Hotspots was initially trained on a BERT model, specifically, or code BERT, trained off of code examples correlated with security findings that humans kind of annotated the code with. And then most of the AI that navigates the code bases and provides historical context is built on top of anthropic models. Most of them, the latest version of the Sonnet model.
Just putting that in chat while you're reading it out loud. Okay, thanks. Any other questions as we get through this? Feel free to throw them in there. Happy to have a discussion about some of these things because we're going to transition next into kind of a real world use case of this, of how we've been tying it together in our implementation of this. So because our goal here, our entire goal here is to keep humans in the loop, we also want to keep humans in the loop on the developer side. And that means surfacing feedback to them, interfacing with them at where they're currently doing their work. So we found the best place to integrate this AI human feedback loop is in the existing place where developers get their feedback today inside their SCMs. That's GitHub or GitLab, Azure DevOps, Bitbucket. There's a common practice in there where developers open pull requests to get code review. We found overwhelmingly that's the preferred place to integrate these findings. It's not at build. It's not at areas where we're still actively developing. There's some value for that, but for the areas we've seen the most success have been at this pull request level where the developers are already expressing an intent to get feedback. And so what we introduce into that process when a code change has been opened, so there's a developer who has a set of codes they want to change, we run two kind of approaches here automatically in the background. The first one is a suite of traditional scanning engines. This is kind of what's current state of the art for shift left looks like. We're running a variety of static analysis tools, infrastructure as code scanners, source composition, secrets detection, a number of custom things. One of the things that's really cool about this is anything that is adding alerts on a code base, whether they're in-house tools or off-the-shelf commercial tools, can get put into this. We also deployed our own model here. Kind of, you already showed an example of it earlier, of just for high-risk changes, asking the question, "Hey AI, do you see any security vulnerabilities here?" We also couple that with the hotspots model that we had. So in parallel to actually running all these scanners on it, we also need to, at this point, categorize the relative risk of that code change. And this is a really essential part of this process of having both the human and the AI understand some concept of risk. Without that, both the human and the AI end up being relatively lost. I want to underscore this repeatedly because it's one of the most important concepts we identified in this. And from there, in a lot of cases, what you're getting out of this is confidence of like, hey, these SAS findings you don't need to worry about. This one we think is a false positive, or there was nothing there, or this is relatively low risk because it's in a unit test. And that amount of context, even if there is some amount of security feedback on there, what we've unlocked with this approach is cutting through some of the shift left noise that just exists in code bases today. And that's valuable in and of itself. We think because even these existing tools produce some value today if you can help developers assess risk and get through get back to being productive. But in a lot of cases, there is actual risk or is actual findings that we need to investigate. And from here, we then feed it into a separate AI model that's all about assessing context. This was the first example where it showed where we've got some questions about a code base, like, is this SAS finding real? Does this line of code in this high risk change identify a security vulnerability? Does this properly fix? And you want a engine here that can iterate on this, is like all this feedback, all of the things, and we need to make suggestions. Do I need to act on this? And if so, what type of remediation should be applied here? That's the fix suggestion we applied at the end. And in all these cases, we think accuracy is getting pretty good. It's getting better, but there's still false positives. It still hallucinates. And so because we don't want to put more noise to developers and we need a training cycle for the AI itself, we think this human in the loop component really is the essential piece to getting value out of AI in 2025. And that means having a really scalable approach to surfacing AI output to humans for review, so that if it's ready and actionable and ready to go, it can be a quick pass through. If there's areas where we need the AI to do more work or the developer to provide more context, that's a human interface to it powered by LLM, but with human oversight. And this was one of the kind of started with this as a temporary working area, and now we've got it to the point where it's so scalable and the developer satisfaction is so much higher by having this human component that we're really thinking that the key to is doing this at scalable, doing this in a scalable manner. And if we can unlock that, this really is the best interface because it quickly gets the AI to improve, and overwhelmingly, developers love it.
And Alex, just to give you just an example about myself, right? Like for
Yeah.
like HackerOne uses pull requests too, and so um, I've been blown away by putting up a code change for review, and even before someone of our own team looking at the code, someone already flagged, someone from the pull request community flagged a security vulnerability already. And just seeing that kind of come together in the tool that I am familiar with, in our case, GitLab, it's so much better than any of the other tools that I've seen in out there.
I'm glad you're a fan. It really is magic when it all comes together. So I want to give you guys a few examples of what this looks like in practice from our tool stores. This was a example of a code change that was happening for this is a authentication function with a key comparison here. And this is the type of thing that traditional static analysis is not going to find. And if you ask AI to just review the entire thing, it's not going to find. But what's happening behind the scenes here is an AI hotspots model is saying, hey, there's an authentication function, there's some keys being compared here, and then a sensitive operation happening. This is high risk. AI, what do you think should happen here? And you're able to get a pretty concise recommendation around this could be vulnerable to a timing attack. Bundling in the fix together, use this instead with a human reviewing and editing this entire output. This is what comes back to a developer in near real time after they propose some code changes. And this is such a better experience than a traditional security tool or a traditional security review process. And it's really magic to see how quick it is to fix something like this. And then, of course, the developer fixes it as part of the pull request, and that it gets a secondary review. Next example I wanted to touch on here was, this is a pretty common area where security vulnerabilities get introduced. This is a developer adding a new front-end component. They're actually doing the right thing here. They're adding some front-end validation on the field here. Again, the hotspots model calls out of there's some input validation happening here. We should review that. Pulls up for the reviewer the definition of the backend function and calls out that I don't see the corresponding validation at the backend. And so this is what we end up calling out back to the code author, is that you added some validation here. That was great. That validation doesn't exist in the backend. Check that out. Next example we've got here, this is the filtering SAS finding use case. This is a really solid SAS finding from an underlying tool. Stack trace information is getting sent out in a developer environment. This is actually a bit more of a sophisticated SAS tool that does actually flag that it's not in a developer environment. The problem with this, just running this SAS tool by itself, is there are still a bunch of scenarios where there are false positives related to this. But what we're able to bundle together is both the initial issue and here's a better way to do this. So you both get the initial SAS finding. You can see that it's been verified by a human along with the remediation suggestion. And this is what we want. This is the entire interaction here was a thumbs up from a developer to say, yep, got it, gets re-reviewed, and we're back out. And the user experience and the productivity benefits between giving just this to the developer and expecting them to build context and sort out false positives versus giving them it as a complete package is just kind of a magical experience for development teams. And then I wanted to put in some more complicated examples. Those relatively straightforward ones, but this one I love, because one of the things that happens when you have these agents back and forth is you can call out some initial risk, and then you can really acknowledge sometimes the fix is straightforward, like the last example. Sometimes the fixes are actually pretty hard. So this was a race condition being called out in some asynchronous function handling, and the fix is not straightforward for anybody. But what you have here between the original code author, a human in the loop, and an AI making remediation suggestions is you can go through this iterative process of providing suggestions, saying like, oh, I tried this thing, that didn't work. What do you think I should try? And you really get to a positive remediation effort. And just like this, like testimonials like this just blow me away where developer is fixing a race condition that was flagged by a security tool. And they're just, I can't appreciate the write-up you did. It makes a ton of sense now. Thank you for this. And it's what shift left should be. This is what the experience should look like. It shouldn't just be, hi developer, you got a race condition here, go fix it. We're training developers real time, it's personable, and we're shipping more secure code as a result. And it's one of the most underappreciated parts of doing shift left well is sometimes fixing things is really hard, and we need to design for that in the overall service. All right, folks. Last thing I want to touch on here, because this was what really ties this all together for approaching shift left, is what is the North Star KPI that we measure? A lot of traditional tools will measure things like false positives rates or time to scan or fix rates. We have over-indexed really heavily on developer satisfaction here. What ultimately matters is, was the developer able and willing to fix the issue based on what we gave them? We capture this in a few different ways. Emojis, just a quick thumbs up or a thumbs down. It's the most common way. Getting a thumbs up instead of the middle finger is what we joke about the North Star being, but also more structured feedback and just general sentiment analysis on how was the code author responding back to this. And we're sitting at 96% satisfaction from code authors of when we surface feedback on a PR, it being helpful and actionable, which I think all shift left tools going forward need to have this as the primary metric that they're signing up to be accountable for. If we're not actually empowering code authors to fix things, what's the point of any of this? So thanks, folks. That's the bulk of the content we had today. We have a little bit of time for discussion. I see there's a few questions we might need to get into, but hope you enjoyed spending some time with us today. Hope we've convinced you that shift left is worth revisiting. If you want to give it a shot with us, our pull request offering is what we've been rolling out, where we've been building these pieces. We really think about it as an early layer of defense in a comprehensive defense in depth approach. We think security is done best when there's multiple layers. And our whole goal in this, if you know us from our bug bounty programs, we want the stuff that ends up in a bug bounty program to be novel, elusive things that only humans can find. And we think there's an opportunity to catch a lot more of this during the software development lifecycle. And I'm pretty encouraged by what we've been seeing there. Gilbert, any final commentary from you, or any questions we should go tackle in the chat?
Yeah, I just realized that I had been sending the answers of questions in the chat to the host and panelists. Great. So clearly do not know how to use Zoom here, but let me just go over them live, and I could post them again in the chat. But question was, how is the AI security managed as code is uploaded to the AI model? Who has access to the AI model content? So just to answer that one first. So the inference endpoints are all hosted within the HackerOne infrastructure, either through AWS Bedrock for Anthropic models or SageMaker for any of the other models. Two, is any of the code used for training a model? So not that persists in a model itself. So the data that we extract is stored per customer in a separate database that is fed to the model at inference time. So these models are entirely stateless in that sense. And third question, what assurances are provided to manage the confidentiality of the code? So we only retain code during the actual review, and it's deleted immediately afterwards. We have a bunch of controls in place to safeguard this, but I would welcome any feedback on this as part of our bug bounty program, if there's a place where you think that doesn't happen. Let's see. Another question talking about shift left. Are IDE plugins planned for both analysis and remediation advice? Um, right now, we're focused on the review stage of the software development lifecycle and not on the development stage yet. I would personally love to shift left even further and bring this to the actual IDEs, but it's not something that we're focused on yet. So uh, surfacing context-aware advice at the time of coding, though, will make this even better. I completely agree.
Yeah, I'll add a little bit onto that. One of the reasons why we focused on the progress level, it's about being where developers are expecting feedback today. When you sit with you're in a point in IDE where if you can surface really actionable type ahead or contextual advice, it can, in theory, be useful. Um, but it's often at the wrong time. Like developers are often writing code, deleting code, reassessing things. They're not yet ready to submit it for review, and too often it's hard to be precise about when is the right time to give someone some feedback on what they were typing. Even if you're pair programming with somebody and sitting alongside them, people kind of have a raw stream of consciousness, and it's not all. Sometimes it's helpful to like just let that complete, and so that's a really tricky nuance to get. Is like developers writing something, AI over eagerly jumps in with a suggestion, and the developer's like, "Yeah, I know, I'm going to write a unit test for that next." Like that's why are you even telling me that right now? But at the pull request level, what's really powerful about it is that there's already an intent there for, I think this code is ready to get merged into production. I want review on it. I need review on it as part of an approval process. And so I think just being mindful in the developer first design of these things, as we're providing feedback, we need to make sure it's at a point in time where the human actually wants the feedback. And it's there's certainly times where that happens in an IE, but it's not always obvious. Um, Tom, will there be recording? Yeah, we'll have the recording for this to share out, folks. All right, we hit the end of our questions. I love giving everyone time back at the end of this. I certainly have email to get to and Slack messages to get to. So if we want to wrap up early, I'm happy to do that. It was really great seeing everyone today. Thanks for the questions. Hope we convinced you that there's some exciting things coming in the world of finding and fixing bugs before production. We've got a long way to go. Yeah, and shoot Yober and I a note if you'd like to see what we've been working on in a little bit more of a production context. Thanks, everybody.
Thanks, everyone.